Hey there, it's me again. Not sure what the title of this video is going to be, but I haven't stopped looking at this aggregation thing. See, it's still in my list here, but you'll notice that a whole bunch of other things have entered into my workspace, and that's because things keep coming up. The more I try to do one thing, or the longer I try to accomplish one task, the more intermediary tasks seem to jump in front. One thing I can tell you, though, with pretty much with 99% certainty, is that there's really nothing at all to this aggregation business. There's nothing more to it than fiddling around with the registry, essentially. That is, it's completely something that is an invention of someone, I don't know who, someone's invention of a scheme, a way to use the registry in order to glue objects together. And the gluing is nothing more than creating an object of one type and exporting it, and then having someone be able to look, well, I have two of these, look that up. How do I end up with two? Oh, right. See, I've been working on this other tray thing, right? So I was wondering how this thing survived. This uses a different two tray. Anyway, I could, if I wanted to, take this MyServe and aggregate into MyServe that simple math thing. Okay, there's nothing to that. All I would do, if I wanted to do that, see, the simple math thing has an add function, right? All I would do is insert an add function to my thing, and when I want to add two numbers, I would create an instance of a simple math and run the add function and then return the value. The magical stuff has to do with these numbers, and how you can tell the outside world that your interface, whoever it is, includes within it another interface. And the way to do that has to do with these type libraries. Now a type lib, let's see if this still works. I just tried Control-Alt-X. And oh, that's what happened, I see. Now, maybe I don't have the key binding anymore. It must be gone. I must have messed it up. Now, see, this is one of the things that's jumped in the way. Watch this. I don't know if it'll work, but I have this batch file, fixsys, which is supposed to repair for me a situation where I've lost my key binding for sending these things to the system tray. I run this batch file, and it kills Explorer and unhides the program that has a keyboard binding. Actually, it does it twice. And now you see that little dialog that popped up there? In theory, if I type now, characters should go into the command box that had the focus initially, and it did. this time, and it seems to be working. So that was one of the problems that, it bugged me. Did it work? That's another question. Control-Alt-X. It will be slow because the system is busy, very busy, but it might be that because I just reinstalled it, I might have lost my key binding as it is. Oh, see, now you see that? This went back here. Oh, well, actually, that's not in this case. No. Okay, I don't have assign key binding. Cancel. Now, normally when you do that with a program, that returns you back to where the focus back to where you were. Right? But if I'm invoking something through a hotkey like this, it's not going to return the focus back to normally back to the program that had the focus at the time of pressing the hotkey. Instead, the focus will go to Explorer, which is completely useless because Explorer is not something that you even use the keyboard with very much. If I hit Escape, it worked. You see what my program now does. I've been having trouble with keyboard focus. What it looks for, in fact, it's not completely finished yet, but what it looks for, first off, is because its parent is actually Explorer, if it's invoked through a hotkey like this, Control-Alt-X, it has to search deeper in the Z order to try and find out what program had the focus before it got invoked. Now, why isn't it? Oh, here it comes. Now, it's not really a coincidence that this box has been selected, even though it's the first thing in the list. Let me try this. No, it doesn't start with 1. Oh, but I could certainly make something here 1. To the audio. Any file. Here. O1. Okay. This thing has a 7 and this has a 1. So if I go here and get out of this directory, Control-Alt-X, it should select in the list which program had the keyboard focus. And the assumption it has. The assumption is that whatever I had selected is the one that I wanted to hide, right? Now that's also considered its real parent, and so when I exit this thing, it tries to return focus back there, which it happened to be able to do. If I hide that thing, that's the case I haven't handled yet. If I do hide the one that has the focus, then where does the focus go? It should go to the next thing that's not Explorer, right? The last thing you want is for it to go to Explorer. And that's the problem I had with that fixed sys. You see how one gets diverted. In any case, if you look at this aggregation complex calculator thing, complex math, which has divide, whereas the other thing has, the simple math has add, and this here is the class ID for the simple math, but that's just the class. The interface ID for the simple math interface is somewhere in here as well. Now I made a bunch of changes in here. Let's see what I can get rid of. No, it doesn't have it. It's got to be here somewhere. Not here. There's a reg file. That might be where it gets. I forget now. Simple math. Okay, yeah, okay. This here is in a special funny language. Interface definition language. A simple math happens to have this identifier and for its interface, not the class. Okay, and forgetting about dispatch and all that. The complex math has this identifier. Okay. Now this other part here is to do with the type library. That's why it's got lib here. That's shorthand for type lib. And that has this identifier. All a type lib is yet another COM object that is meant to support a whole range of functions. And those functions are the things that allow other people who have agreed on a certain protocol to determine what an object can do. There's a program here called OLEView that you have on your system, probably. In here, one will find this D9 something. I don't know if it'll have it by number. No. It should be complex math. There's no search feature in this program, you can believe it. Yeah. Let's see, maybe I can find it another way. This, I think, is by number. I'm not joking. There's no search feature in this program. The one thing that you would expect it to have doesn't have it. So hey, if you want to make $1 million, write another OLEView that has search. What are we looking for? D9. D9 0894. Okay, well maybe it wouldn't come into this category. This certainly, the B6 thing is an interface. It should be there. B6B. Here. No. How about F4? F4. Whoops. A. No. How about complex math? I know I registered this thing. HIKL. Oh, come on. If only there were a search feature. Okay, what else have we got? Library objects. I didn't unregister, but the DLLs might be gone. Let's try that. Any of these. B, I'm near B. Oh, we already checked that. D9. Is that on this list? Oh, what is this? Class not registered. Okay, that could be. Show me. Oh, I see. I see. This is not showing you what's in the registry, but showing you what would one of these type library things possibly might return to you. Because I didn't unregister it, but I haven't built it. It's not currently built. Unfortunately, this thing doesn't show you where the things are going to the registry. See how useful that program is that OLE views. Fantastic. Okay, now this should be iSimple Math, which should be registered. And it has a type library within it, within the same DLL. There must be a type library. A type library is just another COM object. It's not a new idea. Here, iSimple Math. Okay. B6B blah 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 is the type library for iSimple Math. Now this doesn't even tell you where the code is located. You will have noticed. That you can find out, though, I believe, from this type library. But it's all to do with the registry, mainly. And just a convention that a bunch of people agreed on. Okay, you see, now this has come under F4, iComplex Math, which has the same type library, but still, okay, we're looking under classes root interface, not CLS ID. We don't have if we want to find out where all this is located, that should be, that's interface, this thing, DC18 something something, which I don't have as a string, but still search for it. I have to go to class on the DC retard. Okay. Here, math object class. Oh, that's that one. Can't be. Can't believe it. Oh, this is the wrong project. Okay, it's not this file. One of these. This RGS is a registry script. This actually tells you where things are in the registry. Complex calculator, class ID D908. This one. This ought to tell us where the DLL would be. And the reason why this won't work is the DLL is not there. Complex math class. Here. See? I don't even have a debug directory. But I could build it. See, the other thing that got in the way is this thing, which came up again. I wanted to download a complete web page, and I couldn't find that old code because every time I've done that, I've done it in like utest, and I couldn't find it in the history of utest. These things don't depend on anything. It's just two. Now, it's been registered because it's listed here in the registry, the place where you register things, in the registry. Not sure what program ID is. Typelib is the same. Now this typelib is the same typelib as is given for simple math. The idea then is that if you want to create a simple math, if you wanted to, you could pass in a simple math interface see, there's no co-create instance or anything in any of this because it's using this fancy template language, so all that's hidden. But what you would do is you would do a standard co-create instance, the interface identifier for a simple math, and then for the parameter called uncouter of that function, which is normally null. Wait, you need a class ID and an interface ID, such as client, such as test my serve. here. Create instance. You give the class ID of you would give the class ID of a complex math. Now why is this not compiled? And the interface identifier for a simple math. That's all. And because this thing implements simple math, it will generate a simple math and stick that in here. And that's all there is to aggregation. If I can just get there. What have I done? Did I forget a semicolon? Yes. Oh, I messed all this up. I don't know. It's not going to build. I have to get it from the history. What I started doing was replacing all the number defines with what they were. I looked them up and I found them and I replaced, instead of having declare blah blah blah, I had that comment. I commented it out. Here's what you have, right? And then I commented it out and put in what I found in the header files. ATL declare get unknown. I commented that out and put in all the stuff that the macro gives you. And then for this list, I put all that stuff in, right? So there's like no chance that this is going to compile. But if I get the older version, I don't lose anything anyway. Back to where we were. If it builds I was trying to make sense of all this ATL stuff, but you don't want ATL's a bad thing for this to understand this thing through. It's better to just not use ATL at all, and to take. You can just get rid of these completely. These two things. Find out what the simple math does, and then aggregate it into this math thing instead, and show you that there's nothing to it. It's a matter of this pointer unc is going to be a pointer to a simple math. And if somebody wants to get a simple math, right? That's this final construct. ID simple math, get controlling unknown. That just returns this object. They're trying to be more general. Maybe there's this object might also be a sub something. So class ID, but it's not going to. Oh no, yeah. It needs this class ID in order to create a simple math interface. But the controlling unknown is not a simple math. What we're trying to extract is the interface pointer to a complex math using the class identifier of the simple math. And what gets returned is an I unknown. The I unknown can be, okay, no, sorry, now that's getting put into pointer unc here. I see. Okay, never mind. This thing is a simple math. Why you have to pass this in has to do, I suppose, with, how this function is defined, what it's supposed to do, right? You could put null here if I wanted, if I was just making my own thing, but this is supposed to do some specific thing that has to do with all of this stuff. We don't need it. Anyway, I'm blabbing on and not making much sense. And I'm just going to apologize for my slowness. It all has to do with me running into problems to do with the keyboard focus. Surprise, surprise. I wonder what that thing was that didn't open before. Probably open now. Where was it? Maybe S for simple math. HIJL, similarity, simple math. Here you go. You see? Now, this before, I think, probably either it wasn't there before or maybe it would have failed. I clicked on this, but now it's not failing. Simple math class has class ID blah blah blah. Type lib calculator DLL. Okay, so this is the simple math on its own without any complex calculator. If I could find complex math, see, there's simple math.1. What is it called? HILMN com LMNO compact. Here, complex math. Okay. Complex calculator. Complex math. Type lib. No, B6B. I think it's the same type lib as for simple math. And we might find it now in these things. These are type libs. I suppose it would be complex math. Complex calculator. Okay. B6B, right? Now, what about simple math? Where is it? Oh, I don't know. Oh, it was just called calculator, maybe. I forget what it was called. Here. Right, okay. 5D6, calculator DLL. Well, somehow, I've seen it before, where simple math was listed somehow under the complex. Holy, calculator, complex calculator. Type left. There's something missing in here. I need to refresh it. Anyway, whether or not this works, or it doesn't really help us get any further into understanding what is essentially nothing more than one uh, struct making an instance of another struct and exposing the interface through the registry. Oh, wonderful. Okay, and I'll try to get to that next time. Okay, see you.